Welcome to Maths with EJD. In this video, we're looking at the connections of binomial series with power series and other mathematical series. And I suspect that will be the last in the series of the binomial series, although the general sequences and series actually still continue after now because we still have things like Fourier series and the rest of them. Okay, so first off, the binomial series is a specific type of power series and has connections with other mathematical series through its general formulation. Okay, so first of all, let's see binomial series as a power series. What's the connection? Okay, so the binomial series is expressed as 1 plus x raised to power r, which is equal to summation from now we can say n equals 0 to infinity, then r combination n x raised to power n. So we can express it like this, right? And this is only true for absolute value of x less than 1, as we have always said. So where r combination n is the same thing as r into r minus 1 into r minus 2, and that goes on until we get to r minus n plus 1 divided by n factorial. Okay, so here, this is a power series, actually. This is a power series. This is as good as a power series with coefficients. This is a power series with coefficients derived from the generalized binomial coefficient, from the generalized binomial coefficient. So, we can have this kind of example. So imagine the expansion for 1 plus x raised to power minus 1. I think we've done this a couple of times. And we see that 1 plus x raised to power minus 1 is actually the summation from n equals 0 to infinity, n equals 0 to infinity for minus 1 raised to power n, x raised to power n. And of course, that's simply 1 minus x plus x squared minus x cubed plus all that. Okay, so that's about power series. Now, can we also see the relationship between binomial series and say geometric series? In fact, what we've done is a very good example of that, but let's do it a bit better. Two, we talk about relation to geometric series. So the geometric series is a special case of the binomial series when r is equal to minus 1. Okay, imagine that you have 1 over 1 minus x is equal to, which is summation from n equals 0 to infinity for x raised to power n, where the absolute value of x is less than 1. That is 1 lies between, I mean, x lies between 0, minus 1 and 1, right? So look at this example. If we say let x be 0.5, of course, x is 0.5 perfectly meets this condition that x lies between -1 and 1. So in that situation, if we have 1 over 1 minus 0.5, so we say that summation from n equals 0 to infinity for x now is 0.5. So we have 0.5 raised to power n. And that will simply give us 1 plus 0.5 plus 0.25, and that goes on like that. And it gives us 2, okay? Like the sum to infinity is actually 2. Now, I mean, instead of just jumping at 2, right, you can imagine that we already have a pattern. We have 1, 0.5, 0.25. So this is actually a geometric series with the first term, A1, which is 1, and you have the common ratio to be simply 0.5 because 1 times 0.5 is 0.5, 0.5 times 0.5 is 0.25. So if you try the sum to infinity, you get the first term divided by 1 minus r, right? So that is sum to infinity is equal to 1 divided by 1 minus 0.5. So sum to infinity is simply 1 over 0.5, and that is simply 2. So you can see the idea of geometric series is coming up in this situation. So that works perfectly. So you can see that binomial expansion is related to power series just because this 1 minus x now, it's the same thing as 1 over 1 minus x is the same thing as 1 over x raised by minus 1, which of course gives us this kind of expression that we did before, and then we can actually use that to estimate this, which makes perfect sense. So let's move on to the next idea, and that is about how binomial series is related to exponential series. 3, relation to exponential series. Relation to exponential series. So the exponential series, which is e raised to power x equals summation from n equals 0 to infinity of x raised to power n over n factorial, is actually connected through transformations. Through transformations as 1 plus x raised to power r can approximate, as it can approximate e raised to power x for large r, using the fact that 1 plus x over r raised to power r is approximately e raised to power x. Okay, so we can use that idea. So that's the connection right there. So a very good example will be this example. So approximation of e. Approximation of e, that's simply 1 plus 1 over n raised to power n. And that is e as n approaches infinity, as n grows very large. So that expression approaches e. So we can say that binomial expansion has some connection with the exponential series. Okay, then we move on to the next. That's the idea of Taylor series, which I also did a whole. I mean, I did under power series. I talked about Taylor series, so the playlist is also added to this series. This whole playlist on sequences and series. So for relation to Taylor series, relation to Taylor series. So here, the binomial series, the binomial series itself is derived using Taylor expansion, for 1 plus x raised to power r, where each term, where each term comes from derivatives evaluated at x equals 0. Okay, imagine this example. Derivation. Let's look at the derivation for r equals 2, for instance. So you see that f of x is equal to 1 plus x raised to power 2. 1 plus x raised to power 2. What that tells us is that f prime of x rather is just like what we saw just now. I mean, in the previous video, right, that we can differentiate term by term, bring down the power 2, then you have 1 plus x raised to power 2 minus 1. So that is 2 into 1 plus x raised to power 1. That is 2 into 1 plus x simply, okay? And from there, we have f prime of x. That's the second derivative. So, this is as good as 2 plus 2x, right? So when we differentiate this, we just get 2. So as a result of that, if we now form the Taylor series, so the Taylor series gives, it now gives f of x to be equal to the normal thing we would do, right? We have f of 0, when you put 0 there, so this is more like f of 0, okay? You have f of 0 plus f of 0 by 0 factorial, I believe, then f prime of 0 divided by 1 factorial plus f prime of 0. I mean, this will now have x, and this is x squared over 2 factorial. That's actually the idea of Taylor series. So if we put all of that together, now you have f of x equals f of 0. That's if you evaluate this expression. So f evaluated at 0, that's simply 1 plus 0 squared. That is 1 squared, which is simply 1. Then if you do f prime squared, f prime of 0 rather, that is 2 into 1 plus 0. And that's simply 2. Okay. Then if you do f prime of 0, so 0 doesn't affect this, you just have 2. So it means you have 1, 2, 2 coming, right? So f of 0 is 1. 0 factorial is also 1 plus f prime of 0 from what we had, that's 2. Okay, that's 2. 1 factorial is 1. Then you have x plus f prime of 0, another 2 over 2 factorial x squared. And all of that continues. So then you see that so that's f of x, right? That's actually Taylor series in action. So we can then say, therefore, the actual f of x now is 1 plus 2x plus 2, plus x squared, because 2 cancels 2 factorial. So it's actually, so 2 cancels 2 factorial because 2 factorial is 2. So that's plus x squared. And that's what exactly we have when the power is 2. So, and you can say that this uh matches 2 combination n x raised to power n for sure. That matches that very clearly. Or better still, this matches the summation from n equals 0 to 2. 2 is the power now. Then 2 combination n x raised to power n, because at 0, 2 combination 0 is 1 for sure. Then x raised to power 2 combination 0 is 1. Then x raised to power 0 is x raised to power 0 is also 1. So this is power n. So then next, if you go to 1, 2 combination 1 is 2 that we have here. Then x raised to power 1 is x. Then next you have 2 combination 2. 2 combination 2 is 1. Then x raised to power 2. So you see these two are perfectly the same thing. So in essence, we are saying that f of x which is 1 plus 2x plus x squared, is actually similar to the summation from n equals 0 to 2 of 2 combination n x raised to power n. So you see that that's a relationship with power series. So then we can say that these connections highlight the binomial series as a cornerstone, for exploring and connecting various mathematical series, various mathematical series. Okay, so with this, I come to the end of this video. If you have not subscribed to this channel, you'll be missing a lot, right? So subscribe, hit the notification bell so you can always get alerted each time a new video is released. Then comment, let me know how useful these videos are to you, and also let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. And at the same time, like and share so that more people can have access to this great learning. Till I come your way again, keep doing maths right. Bye.